Greetings, ladies and gents, and welcome back at Sam Mathematics Science Club. In this video, we'll be looking at a question which was written in November 2021. It's a question on analytical geometry. So you can also find these type of questions also in grade 11s, but of course in grade 12 they also pop up a lot. So in this case, they say that triangle TSK is drawn. The equation of ST is y is equals to a half x plus 6, and ST cast the x-axis at M. They say that W is negative 4 is to 4 lies on a ST, and R lies on SK such that WR is parallel to the y-axis. WK casts the x-axis at V and the y-axis at P, which is 0.0 is to negative 4, and they say that SK produced cast the x-axis at N, and they also say that SK is equals to theta. So in this case, of course, what we can also note, which didn't say in the diagram, is that of course we also have theta, we also have beta rather. So in this case, we have also that angle there. Now, for 3.1, they said that calculate the gradient of WP. Now, I'm sure that should be fairly simple. So in this case, how would you calculate the gradient? So in this case, to calculate the gradient of WP, so M of WP, so in this case, this simply B equals to Y at W minus Y at P. All of that is divided by X at W minus X at a point P. So this would be now the Y coordinate at W. We know that of course that's 4, right? So that would be 4 minus Y at P. So this would be negative 4. So this would be minus 4, right? All of that is divided by X at W. So that's negative 4 minus 0 in this case. So if you put that into the calculator, so what you would get would be no. Now we have 4 minus 4 divided by 4, which is divided by negative 4 rather. So in this case, this is actually negative 4. All right, so in this case, what would have there would be a negative 2. So we know that of course the gradient of WP is simply equals to a negative 2. So they said that show that WP is perpendicular to ST. Now, how would you show that two lines are perpendicular? Well, it's pretty simple. What you would do in this case, you would take the gradient of one line and then you would multiply it by the gradient of the other. So if the product of those two gradients gives you negative 1, so that would mean that those two lines are perpendicular. So in this case, what I'm going to do is that I'm going to multiply the gradient of ST, all right, and of course of WP. So if the product of those two gradients gives me negative 1, then I would conclude that that is actually, so those two lines are actually perpendicular to one another, meaning that they make an angle, where they meet, they make an angle of 90. So what I'm going to do, so this was for 3.1, right? So this was for 3.1. So that's what for 3.1. So for 3.2, so what I'm going to do, I'm going to multiply the gradient of WP, right? So M of WP multiplied by WP multiplied by M of that line ST. Now remember, we actually have the gradient of ST. They said that of course the equation of ST is y is equals to a half x plus 6. So in this case, that negative half is actually the gradient of that line ST. So in this case, what I would have, let me just erase that so that it doesn't confuse. So in this case, this will simply be equals to, so in order for the gradient of WP, that was negative 2. I to multiply that by a half. So what you would get eventually would be a value of negative 1. So in this case, since the product of those two gradients, so in this case we've shown that that WP is indeed perpendicular to ST. So in this case, the following equation, they say that if the equation of SK is given as 5y plus 2x plus 6 is equals to 0. Now that line SK is actually a straight line. Now normally the equation of a straight line, so this would be for 3.3, right? So for 3.3, now normally the equation of a straight line goes like this. So it's y is equals to mx plus c, right? Now in this case, y would be the substitute of the formula. So what I'm gonna do is that I'm gonna make this y the substitute of the formula in that equation, so that now if I do that, now remember I have 5y. So if I of course try to do that, what I'm gonna do, I'm gonna transpose the rest to the other side, right? And then of course leaving that 5y. So in this case, what I would have would be 5y right, being equals to negative 2x minus 60. Then of course I would divide by 5 on both sides. So in this case I would have y being equals to negative 2 over 5, right? So that's 5 x minus 12. We know that for 60, negative 60 divided by 5, that gives us 12, if I'm not mistaken. So in this case, we would know that, of course, now we actually have the equation, right, of that line, which is sk in its standard form. Now, what they are requiring us to do there would be to calculate the coordinates of s. Now, why did I put that in that? Why did I actually convert, or why did I put it this equation in that standard form? So the reason why I did that was because I know that, of course, this line here actually meet with this line at that point S there, right? So what I would do in this case, to find the point of intersection of any of two lines, right, to find the coordinates of those of that point of intersection. So in this case, what you would do, you would actually equate the equations of those two lines. Now, why would I do that? So the reason for that would be, now remember that at that point of intersection, at that point S, now remember that those two lines share that point S, right? So whatever x value that I get using this line, the equation of this line, will actually be the same. I would actually get the same coordinates when I use this equation here. So in this case, what I'm going to argue would be that, of course, now what I'm going to do is that, and remember I said I'm going to equate these two equations, right? So in this case, the other equation, now what would be the equation of this line? We said that was actually y is equals to negative 2x plus 6, right? And then, of course, you already have the equation of that line. So in this case, what I would do in this case, now I'm just going to write the equation of that st first. So in this case, I know that, of course, we have y being equals to a half x plus 6. So what I'm going to argue is that the y coordinate of this line at that point would be equals to the y coordinate of this line at that point S. So in this case, I'm going to say y is equals to y. I'm just erase that. So this is x plus 6. So in this case, I'm going to argue that y is actually equals to y. So in this case, what I'm going to do, I'm going to say right now, what I have would be, I have negative 2 over 5 x minus 12, right? So that would be for that equation, right? So in this case, so this would actually be equals to a half x plus 6. Now what I'm gonna do from this table, I'm just gonna collect like terms. So in this case, I would have negative 2 over 5, right? X minus a half x. So this would simply be equals to 6 plus 12. Now remember, when I transpose this to the other side, it becomes since it was negative, it becomes positive, right? So in this case, what I would do for, of course, from this step, so what I would do would be, of course, to add these two. So in this case, what I would do would be to say that what would be the value that I would get when I take negative 2 over 3, negative 2 over 5 rather, if I take negative 2 over 5, and then, of course, I minus 0.5 there, so I actually get 0.9, right? So in this case, I have 0.9 x being equals to, now you can convert that, of course, into a fraction, but in this case it's actually a little bit better now in that form there. So in this case, what I would do would be just to leave it in that form. So in this case, I have negative, rather negative 0.9 x. In this case, 6 plus 12, that's actually 18. So this would be 18. So this will simply be 1/8. So we have 1/8 on that side. So in this case, what I would do would be to divide by 0.9 on both sides, or negative 0.9. So this would be divided by 0.9, divide that by 0.9. So what you get from that, so in this case, you know that, of course, those cancels. So these cancels. So in this case, I'm only left with the x. So let me just scroll down so that I have somewhere to write. So in this case, I know that, of course, x. Now I'm only left with x. So in this case, 18 divided by negative. Since 18 divided by a negative 0.9. So what I would actually get would be x being equals to negative 20. So that would actually be the x coordinate of S at that point. Of course, the x coordinate of where those two lines intersect, which is at point S. So in this case, I already know the the x coordinate of point S being negative 20. So in this case, to find the corresponding y value, well, it's pretty much simple. What you would do in this case would be, you can take any equation. It doesn't matter whether you take this equation or you take this equation. So what you're going to do will be just to take that x value, you substitute it on any of those formula, and then find the corresponding y value. So in this case, if you do that, would be, so now I'm just going to take this equation that we have here, because it seems a little bit simpler. So in this case, I have y being equals to a half x plus 6. So in this case, I'm going to sub that x equals to negative 20. So where there's x in that equation, I'm going to substitute that negative 20. So in this case, I have y being equals to a half 20, negative 20, plus a 6. We know that, so let me just put that into the calculator. So in this case, we have 0.5 negative 20. What am I doing now? Right, so we have 0.5 negative 20. All right, in this case, plus a 6. So you'd actually get a value of negative 4. So we know that, of course, y would be negative 4. So in this case, when x is equals to negative 20, y would be equals to negative 4. So now I know the coordinates of s to being now s. So in this case, s would actually be negative 20 is to negative 4. So those would be the coordinates of that point s. So that's negative 20 is to negative 4. Right, I'm just going to erase everything so that we have somewhere to write in this case. Now we said that, of course, the gradient of that line, which was a WP, we said that was actually negative 2. Let me also just write that down in case if we need it. So we have that being negative 2. So in this case, let me just erase what we have happening here, so that, of course, we have somewhere to write for the, of course, for the first question, for the next question rather. So in this case, for question 3, let me just put this calculator to the other side actually. So in this case, for question 3.4, they said that calculate the length of WR. Now where's WR? So it would actually be this line. Let me erase also what I have up here on my diagrams. Right, so in this case, what I have, what they're actually asking would be the length of this line, WR, right? But in this case, if you note very carefully, is that we know, now they say that, of course, this line is actually parallel to that line, right? Meaning that the x coordinate, of course, of that line at W would actually, so any point, right, that is below or above that point W actually have, or would also have an x coordinate of also negative 4. Why? Because that's actually a straight line. So in this case, we know that on that line we actually have the same x coordinate. It doesn't change. The only thing that changes in that line would be the y coordinate, right? So as we go down, in this case, the value of y in this case becomes smaller and smaller, and then, of course, as we go up, it becomes bigger and bigger. But in this case, we know that, of course, the x coordinate remains the same. Only the y coordinate changes, right? So in this case, what I'm going to argue would be to say, right, in this case, so already I already know the y, the x coordinate of that point R to be what? To be negative 4. Why? Because I know that, of course, that on that line, I know that, of course, x is equals to negative 4, right? So in this case, I know that, of course, x is equals to negative 4, right? So meaning that R x is actually equals to, or let me say x at R rather. So x at R is actually equals to negative 4. So now, if you note carefully, we know that, of course, that point R is actually on that line here, and we actually have the equation of that line sk. So what I'm gonna do, I'm just gonna substitute that x coordinate on that on the equation of that line, and then just find the corresponding y value of that. So if I do that now, remember that, of course, that equation was saying that y is actually equals to a negative 2 over 5 mod x minus 12. So in this case, to find the corresponding y value of that when x is equals to negative 4, so what I would do would be just to substitute negative 4 where there's x on that equation. So in this case, I would have negative 2 over 5 multiplied by negative 4, in this case minus 12. So if I put that into the calculator, let's see what we get. So we have negative 2 over 5. We multiply that by negative 4. we minus 12, right? So we subtract 12. So in this case, what you get would be negative 10.4. So that would be the corresponding y value of x, of course, when x is equal to negative 4. So in this case, what I would have would be negative 10.4. So in this case, I know that point r, in this case, have coordinate negative 4 is to negative 10.4 there, right? So in this case, of course, to calculate that length there, I'm just gonna use the distance formula. Now there is, of course, another equation that students use, which is a great one, but in this case I'm just gonna stick to what's actually on the formula sheet rather, which is the distance formula when I have, of course, 2 points. So in this case, what I'm gonna do, I'm just gonna say, right, the length of WR, right, is actually equals to under the square root of x at W minus x at R, we square that, plus of course, say plus y at W minus y at point R, we square that. So in this case, if I substitute there, so I still have that square root there. Alright, so in this case, what I have would be x at W, so that's actually negative 4. So this would be negative 4 minus at what about at point R? We say we would also have negative 4, right? It's the x coordinate at that point. So this would be minus a 4, but we square that, plus y at W, which is 4, minus 10.4, no, because we know that, so we square that. We know that, of course, the y coordinate of at point R would be negative 10.4, right? That's what we calculated there. So in this case, I know that I'm just gonna put that into the calculator. Let's see the value that we are gonna get. I can assure you this is actually already 0 there. So in this case, what I would have would be, of course, 0 to keep this consistent. So this would be 0 plus 4 minus 10.4, but in this case we square that, so you actually get a value of 14.4 units. So that would be the length of that line WR. So in this case, I know that this actually equals to 14.4 units, right? And also I know that, of course, that point R, now it's actually coordinates negative 4 is to negative 10.4. So in this case, I know, of course, the coordinates of that point, of course, in case if, of course, I need it, of course, for the future. So they said that calculate the size of theta. Now, where is theta? Wow, there is theta there. There is theta there. So what I'm gonna do now, there are actually two ways, actually many ways I can think of. In this case, we can actually find that that value of theta. But what I'm gonna do, I'm just gonna use the simpler one, ladies and gentlemen, so that it's not confusing. The point is that we want everyone to get all of these marks. So in this case, let me just erase what we were doing there, so that, of course, we have some way to write. Since of course that's a 5 marks. So what we're gonna do, all right? Now, we know that, of course, that theta there would be the exterior angle of that triangle that we have right here, right? But at the same time, this angle here, beta, would also be the exterior angle of this triangle that we have happening there. So what I'm gonna do is that I'm gonna actually let that angle M, that WMP, that angle WMV to be equals to alpha. So I'm gonna let, just start this. I'm gonna let W. I'm gonna let W M MV being equals to alpha. All right. So in this case, what I'm gonna do, I'm gonna now remember that. So what I'm gonna do now, here's the strategy, right? Where I'm actually going with this. So what I'm gonna do, I'm gonna find that that angle there. In this case, so after I find that angle, so in this case, I know that, of course, that angle would actually be the same as that angle. Why? Because they're actually vertically opposite angle. So in this case, if this is theta, so if this is alpha, so if this is alpha, this is also alpha. Right, so what I'm gonna do, I'm gonna find that alpha, but in this case using the angle of inclination of that line, which is which is SW. So in this case, to find that angle of inclination, that alpha there, in this case, what I'm gonna do, I'm gonna say, right, so I know that of course to find the angle of inclination of any line, I would simply just say tan of alpha is equals to the gradient of that line, which would be the gradient of SW or SM or ST. So in this case, this would be the gradient of ST. So this would be ST, right? So in this case, I know that now. Remember that what I would have in this case would be 10 of alpha. Being now, what would be the gradient of ST? Now they actually told us in the statement, right, that of course we actually have the equation of that line to be y is equals to a half x plus 6. So in this case, that half would be the gradient of that line. So in this case, I know that of course the gradient would be simply equals to a half, right? So in this case, I would know that alpha would simply be equals to 10 -1 or arc10 a half, right? So what I would do in this case to calculate that, so I have 10 arc10, right, 0.5. So in this case, I actually have 26. I have alpha, right? So we have alpha there. So we have alpha being equals to 26. Now I'm not gonna round that off. Actually, I'm just gonna keep it to 4 decimal places. So in this case, I have 26.556 5. So that's actually 565, not 555. So that's 565.051. I'm just gonna keep it to those decimal places. Now you remember that you're not allowed to round off unless it's the final. It's your final answer, right? So in this case, I know that alpha is actually equals to what, to 26 point that decimal there. Now what I'm gonna do next would be to find the angle of inclination of that line there. Now remember that of course that line has actually a negative gradient, right, which we found. So in this case, which we have as now remember that we know the equation of that line of n k to be, of course, we said that was actually y was actually equals to negative half over 2 x plus minus 12, right? So in this case, we know that of course the gradient of that line is actually the value of m, which is the gradient, is actually equals to negative 2 over a 5. So what I'm gonna do to calculate that beta, I'm gonna say, right, so in this case, I know that of course to calculate that beta, I would say that 10 of beta is actually equals to m of that line, the gradient of that line, which is of sk. Right, so in this case, now if I continue to do my mathematical gymnastics there, so what I would have would be 10 of beta being equals to negative 2 over 5. Now that negative there, it actually tells you that in which quadrant would you find your solution. So what you need to ask yourself is that in which quadrant is 10 negative. So we know that of course 10 is negative. So this is this would be, all of them would be, so this is all station to Cape Town. That's of course the mnemonic that we normally use to remember that cast diagram. So in this case, we know that of course 10 would be negative in this quadrant and in that quadrant. But remember that in this quadrant, on the fourth quadrant, we know we have 360 minus let me just say beta, right? Then of course we know that of course on the second quadrant we have 180 minus beta. But what you need to note is that that angle beta there, it can't be, there is no way it's gonna be bigger than 270, right? Or there's no way it's gonna be bigger than 180, I should rather say. So in this case, this can't be where we're gonna find our solution. So in this case, this only solution that would be applicable in that scenario would actually be in the second quadrant. So we know that of course that that angle of beta there, the numerical value of that would actually be greater than 90, right? So in this case, so in all cases, this is in all cases, ladies and gentlemen. So in this case, we know that of course when you take when you're calculating the angle of inclination of a line that is a negative gradient, the solution is always in the second quadrant. So that's one thing that you must always remember. So in this case, I know that of course my solution is in the second quarter. So I'm just gonna calculate the reference angle of beta. So in this case, I'll say ref of beta is actually equals to 10 of 2 divided by 5. Now you see that of course I left that negative there, right? So in this case, I know that what I would have would be arc10. All right, so in this case I would have 2 over 5. I actually wrote something else there, so that's shift 10, right? So that would be 21.8801409. So I know that of course the reference would be equals to 21.801 of course some other dots. So in this case, to find the angle of beta, now we said of course that solution will actually be in the second quadrant, right? So in this case, I know that beta, let me just use another color. So in this case, I know that of course beta would simply be equals to 180 minus the reference angle of beta. Now in this case, I know I'm just gonna avoid writing all of that. So what I'm gonna do, I'm just gonna say 180 minus 10 of 2 over 5. Rather in this case, so in this case, I know that of course we would have 180 minus the reference angle there. So in this case, I know that of course that value would be, so in this case I know that of course this would be beta. So I know that beta would simply be, that's not a beta anymore. So I know that of course beta, making a mess now, so that's beta would simply equals to 158 and 158 119 8 so that would, let me just scroll that up. So we have 1985 9, yeah, let me just leave it to that. So in this case, I know that of course that angle of beta is actually 158 1985 and 9 of course degrees. So in this case, what I'm gonna do is to say, right now, remember, if you look of course on that line there, now remember they want us to find the value of theta, right? But what I'm gonna do is that I'm actually just gonna find this angle here. Now what would that be angle be? So that would actually be 180 minus theta, right? So in this case, I know, let me just let's see, I'm just gonna leave that. Actually, let me just scroll down rather, so that we don't erase a lot of things there. So in this case, let me just erase what we have here. So in this case, I know that let me erase that. So of course I know that of course that angle there that we have there, right, would actually be so in this case, let me just say N S M would simply be equals to 180 minus theta. Now what I'm gonna argue is that I know that of course that that angle, which is beta, right, is actually equals to the sum. So you notice of course that beta is actually the exterior angle of that triangle there, right? So in this case, I know that of course that the exterior angle is equals to the opposite to the sum of the two opposite interior angles, right? So which would be alpha, and then of course that angle there. So in this case, I know that of course beta would simply be equals to 180. We said that of course NSM would be 180 minus theta, right? So in this case, you have 180 minus theta plus alpha. That I hope that makes sense. So in this case, I know that beta would be, we say that's 158.859 I'm just gonna keep it to that. So this would actually be equals to 180 minus theta plus alpha, which we go to be 26.56505. Let me just erase of course also what we have happening right here. Let me just erase that. So in this case, what would have, let me just scroll that down. So what would have in this case would be alpha being 26.56505, right? So in this case, I know that of course theta, what I'm gonna do, I'm just gonna take this theta to the other side, and then of course I'm gonna take everything that is to the left to the right. So in this case, I would have actually so I would have theta, right, as positive, being equals to 180 plus 26.6505 minus 158.11. Was that the value there? So that was actually 0.19. I'm actually thinking that's actually a 1 there. So that's 19, 859. So in this case, you just put that into your calculator. Now remember, this when it gets to the other side, it becomes negative. And of course, in this case, we had that 26 point something already on that side, and then of course also 180. So what I'm gonna do would be to say, right. So I know that that would be 180 plus 26.56505, all right, minus 158, minus 158.1959. What was the other value again? So that was actually 19, it's actually 1985, 19859. So in this case, you actually get alpha, theta being 48.367. So in this case, we do know that of course theta would be 48.37 there. So that would be the value that we would get for that one. So in this case, we know that of course the theta would be that that 48.37. So the following question, so let me just label that. So we know that of course alpha now is 48.37. So I'm just gonna write that down again in case if we actually need that in the future. So in this case, the last question, they say that let L be a point in the third quadrant such that, so let me just scroll up, so we go to our diagram. So in this case, they say, let me just erase that again. Forgive me, ladies and gentlemen, about the erasing, and of course taking a lot of time there. So let me just erase, of course, what I think is not important. So in this case, they say that let L be a point in the third quadrant such that WSL, so we have a point L, right, in the quadrant, in that quadrant. All right, I'm just gonna put it there. I hope that will be the right place. So they're saying that let L be a point in the third quadrant, so that SWRL in that order forms a parallelogram. So in this case, we have S, right? Let me just take the highlighter, and so in this case we have S. Let me just take the pen rather. So we have SWL, right? In this case, R. So they're saying that's actually a parallelogram. So in this case, I know that of course that is parallel to that, and then of course that would also be parallel to that line there. So this would be point L. So they're saying that calculate the area of SWRL. Now there isn't a direct way to calculate that that area of that quadrilateral there, of that parallelogram, but we actually know that of course this line, it actually cuts that parallelogram in half, right? Meaning that if I calculate the area of this triangle, so in this case that area would actually be the same area that I would actually find if I were to calculate it using that side there. So I know that of course the area of that quadrilateral will simply be the area of this, right, plus the area of that. So what I'm gonna do would be to say, right, now I know that of course I have that angle theta there. All right, now if you check there, we don't have perpendicular height, so in this case we can't use the normal half base times perpendicular height. But in grade 11 we learned of the area rule, right? So in this case, I know now I don't know that length, which is SW, and I also do not know that the length of S of SR there. So what I'm going to do, I'm just going to calculate those two sides, and then I'm going to use the area rule to calculate the area of that triangle there, which would be SWR. So in this case, I'm just going to calculate the length of that WR. So we actually, yeah, we're actually calculating the length of WR in that equation on that was it 3.4. So in this case, I'm just gonna calculate the area. All right, I mean the length of WS. All right, so WS would simply be equals to under the square root x at W minus x at S. We square that plus y at W minus y at S. So we square that. So what I'm gonna do in this case would just be to substitute. So what I have, I know x at W was we know that's -4 minus x at S. So what would be x at S? So we said of course the coordinates for that point S was actually -20 to -4. So this will be minus 20. We square that plus y at W. That's actually a 4 minus y at S, which was actually, so that was actually -4. So this will be minus 4. We square that. So I'm simply just gonna put that into the calculator, ladies and gentlemen. So what we have there would be under the square root. We say that we have -4 minus 20. We square that plus we have 4 minus 4. We square that. So what we have in this case is a fraction. I'm just gonna leave it as a set now in that set form. So in this case, I know that of course we would have. Let me just take it to the other side again so that I can scroll down. So in this case, I know that of course that length would simply be equals to. So in this case, I know that this would simply be equals to. So in this case, I know that this simply be equals to, what was that value again? So we have 8 root 5 units. So in this case, I know of course that length. So what I'm gonna do in this case would simply be to calculate now the length of SR. So what I'm gonna do, I'm also gonna use the distance formula. So in this case, let me just leave it there. So in this case, I know that of course SR would simply be equals to under the square root of x at S minus x at R. Square that plus y at S minus y at R. Square that. So in this case, this will simply be equals to. So we have x at S. We found that of course to be -20. So this will be -20 minus x at point R, which is actually equals to -4. All right, so that's actually -4. So this would be -4. So yeah, in this case, this would be -4. All right, but this would be minus 4 rather. So that's minus 4. Let me just write that in a better way. So that would be minus 4. Right, we know that of course the x coordinate so this would be -20 minus that 4. So in this case, this will be plus. Now when we square that, this will be plus y at S. We say that y at S, that was actually -4 minus what would be the y coordinate. Of course, at that point R, we said that's -10.4. This would be minus 10.4. But we square that. So let's see the value that we're going to get there. So we have square root and -20 minus 4. We square that plus we have -4 minus 10.4. So we actually find that to be a very strange value, which yeah, we haven't squared yet. Still, it's still actually very strange. But anyway, that's what we got, eh? So we actually have 16. I'm not gonna round that off, unfortunately, under the square root of 26. All right, all over 20. So that's all over 5. So we know that of course we have 5. So that's over 5. Right, now what I know now, what I'm gonna do, I'm just gonna calculate the area. So in this case, the area of in this case of that triangle. All right, now Oh yeah, of course. So in this case, the area of that triangle that we have up here. So this triangle, just scroll that again. So of course, in this case of this triangle here, so we have the angle in between, we have the two sides. So in this case, what I would have, or what I would do would be to say, so in this case we have the area of, what was that triangle? That was actually SWR. So in this case SWR, so that triangle of SWR simply equals to a half AB multiplied by the sine of the angle in between. In this case, I'm just going to leave it as C. So in this case, it will simply be equals to a half. One of the sides, which is 8 root 5, multiplied by B, which is that very strange value. So that's 16. So under the square root of 26, divide that by 5. But in this case, we multiply by the sine of the angle in between, which was sine of, which would be sine of 48.37. So that's 48.37. Right, so if I put that into the calculator, let's see what we're going to get. So in this case, we have 0.5, multiply that by 8 square root 5. Alright, so in this case, this will simply be, so that's 16 root 26 divided by 5. And then, so we would actually multiply this by sine of that angle, which was 48 point, that's what, 48.37. So that's actually 109.0. So that's actually, let me just scroll that again. Let me just take it to the other side. So in this case, if I scroll that down, this case, actually I've run out of space actually. So in this case, what I would have there would be that 109.08473 9. So what I would do in this case to calculate the area of that parallelogram in this case, now remember we said of course that parallelogram is actually cut in half. If I find the area of the other one, so in this case the area of the other one it will simply be the same, right? So in this case what I'm gonna say would be to say, right, so in this case the area of the SWRL is simply equals to 2. So this would actually be equals to 109.084739, multiply that by 2. Right, so in this case, if you do that, I'm just gonna multiply whatever the value that we got there by 2. So in this case, I'm gonna multiply all of that by 2. All right, I'm just gonna, let me close the bracket on this side. So we actually have 218. Right, so let me just put that side. So in this case, we have 218.17 units squared. So that would be the area of that quadrilateral that we have there. Now, this is actually the end of this video. I apologize for making it, very long. The explanation, it quite, it takes time. So in this case, if of course, if this video helped you at some point, be sure to like. If you have any questions, you're more than welcome, ladies and gentlemen, to ask in the comment section. And if you have a question that you would like me to do, you are more than welcome to suggest that in the comment section. Now, there will be more questions like this, of course, to follow. So if you haven't subscribed, please consider becoming part of this growing community. But as the story always ends, ladies and gentlemen, this is Sir Mike signing out. Sharp, sharp.